Alright, so these are the ACE questions. Very easy. I'm just gonna start. Alright, this is the continuous function. And basically what they did is they didn't graph f, they graphed f prime. So this is the derivative. Alright, and they're saying, are there any values of x for which there's a relative maximum? Anything for a minimum? Check where it's concave upwards, or check where it's a point of inflection. To do this question, it's very similar to the top question in chapter 3.2, if I'm not wrong. And I told you that to do this, it's very important to make sure I'm recording. It's very important to do the table of variation. What's the table of variation? Do it like this, alright? And the first step to do when looking at this graph of f prime of x is study f prime of x. How does it behave? I did it like this when I was doing the tops. From 0 to 2, we're increasing. So what I do is I write down from 0 to 2, f prime of x is increasing, and then at 2 it like just stops. Alright, then from 2 to 6, it decreases. Then from 6 to 9 to 10, actually 6 to 10, it increases. So what does that mean? If f prime prime of x, so if f prime of x is increasing, that means that the derivative of it is positive from 0 to 2. Then if it's decreasing, then it's negative. Same thing here, positive. Alright, the third step is to check our zeros. Alright, you check out your zeros. Where do we have zeros? We have zeros over here at 2 and at 9, right? So we're going to put 0 here at 2, and we're going to put a 0 here at 9. Alright, cool. Now, the last step to do is to fill in f of x. You need to check whether f of x is increasing or decreasing. So, to check that, you check f prime of x. If f prime of x is negative, then f of x is what? Decreasing. If f prime of x is positive, then f of x is what? Increasing. Nice. So over here, the function is decreasing all the way from 0 to 9. So from 0 to 9, we're going to put it decreasing, and then after 9, it turns positive, so that's when f of x increases. Alright, so we're going to put it like this. Okay, now we can solve any question they want. So I want to just mention that in the top question, in the derivative, they didn't include the endpoints. So مثلا for the top question, they said x between 0 and 10, like this. Here, it's including. Why? Because it's square brackets. I'm not saying in the question in the top they put it in square brackets. They said minus 9, they put square brackets, and then in part A they said for x between minus 9 and 9. Let me show you. So see here, from minus 6 to 6. Like here in the question they said they included it. See, it's less than or equal, and then here they said strictly between. Okay, so that's why here we didn't include minus 6 and 6. But the rule of thumb is to always include the endpoints. So over here we're gonna include 0 and 10 because they didn't say not to include it, and come in, it's a closed interval. Alright, anyways. So when do you include it? Only if it's a closed interval and they didn't say anything otherwise. Alright? Anyways. Alright, so which ones are the local maximums? أول شيء, it's very important. In the local maximum, it can either be at the endpoints, so at 0, at 10, because these are the endpoints, and then where f prime is equal to 0. Let's check our zeros. We have here 1, 0, but over here, is there any change, increase, decrease, or decrease, increase? No, it continues to decrease before and after the 0. Let's look at this 0. In this 0, it's a minimum, it decreases and then increases. Is that a maximum? No, that's actually minimum, so I'm going to write beside it min. Okay, so the only maximums that we may have are at 0 or at 10. Now, how do you figure this one out? You need to think about it like this. You're starting at x equals 0, and you're decreasing all the way. So obviously, it's kind of like making a graph like this. You start at x equals 0 and you just decrease. So obviously, where would the maximum be? Over here. Then you're gonna say, how about x equals 10? We're saying relative maximum, not absolute maximum. After it reaches 9, it increases for a bit. So in this neighborhood, which one will be the maximum? This one over here. Okay, so this is how you look at it. You're talking about relative maximum, not absolute. So you look at the neighborhood only, and in the neighborhood this is the highest. Okay, so that's why 0 and 10 are both maximum. Type, how about part B? Find the value for which absolute minimum. We just agreed that absolute minimum would be this 9. Why? What would the justification be? This, by the way, the table of variation is enough to show all your work. Okay, this is enough. ماشي. You'd say إنه f of x decreases, then increases at x equals 9. Or before you could say no, say before x equals 9, f of x decreases, and then after x equals 9, f of x increases. Okay, and then over here for part A, are there any values for which assumes a local relative maximum? You just try to say, you know, after x equals 0, f of x decreases, meaning that it's the highest in its neighborhood. And then say for the one for x equals 10, because I told you here there's two answers, 0 and x equals 10. Then for 10, say I can show you the solution, by the way. It's right here, over here. So they said this, and then f has over here. So it's then they said it's increasing from 9 to 10. So that's why at 10 is gonna be the maximum of that interval. Anyways, so that's the sort of justification. Anything, as long as you have this, this is gonna guarantee you the full mark. But of course, plug in the correct answers. Anyways, part C, find the intervals over which f is concave upwards. So that means f double prime is positive. Let's take a look. When is f double prime positive? It's positive between 0 and 2, and between 6 and 10. Not 6 and 9, 6 and 10. Okay, so between 0 and 2, and between 10 and 6. Let's just check this. Is that correct? Yeah, 0, 2, and 6, 10. Obviously including, huh? Including. Part D, given all values for x for which f has a point of inflection. Basically, point of inflection is where it changes concavity. So over here at 2 there's an inflection point, and at 6 there's an inflection point, because that's where it changes concavity. And let's check this, 2 and 6, because f prime changes from increasing to decreasing. Or you could just say because f double prime changes sign at these points. Okay, that's so easy. Alright, now we're gonna jump to question 1 and 2 over here really quickly. So far, how long is our recording? 8 minutes. Good. That's good. That's good. That's always good. This one's I think easier than the last one. Alright, so again, this is the graph of h prime, not h. What they're saying, given this is a twice differentiable function, blah 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 blah, the abscissas, whatever, okay, are indicated on the graph. Alright, so we have, you know, some, you know, points that are labeled. Cool. They said part A, determine the values of x for which h has a relative maximum and a relative minimum, and then inflection point, and so on and so forth. So to do this again, we're going to go through our table of variation. So I'm going to go a bit faster. Alright, always x, f of x, f prime, f double prime. Obviously in this case we're talking about h, so you change it instead of f of x, h of x, okay? H prime and whatever. Alright, so let's study the behavior. You can see that we're decreasing up until -1. So from -3 to -1 we're decreasing. Then from -1 up until 1 we're increasing. Then from 1 to 4 we're decreasing. Then from 4 to 6 we're increasing. Cool. So what does that mean about our double prime? If we're decreasing, then we're negative. If we're increasing, it's positive. And if we're decreasing, again, it's negative. And then here again it's positive. Cool. Then we said let's take a look at the zeros. Our zeros are over here at 0, at -3, at 3, at 5. Alright, so we're going to put one at -3, so we're going to put the 0 here. We'll put one at 0, so one over here at 0. One at 3, so another one here. And then one at 5, so one here. Alright, cool. So we have 4 zeros. Then our last step is to what? check the f of x. Let's see, we're negative from negative 3 to 0. We're under the x-axis, so from negative 3 to 0, since we're negative, that means f of x will be decreasing from negative 3 to 0. Alright, then it's going to be positive from 0 to 3. Then from 3 to 5, it's going to be negative, so decreasing. Then from 5 to 6, we're above, so it's positive. Alright, cool. So we have a lot going on. Determine the values of x for which h has a relative maximum and a relative minimum. Let's start our sheet with our endpoints. Let's list what are our two possible values. The first ones you should always list are your endpoints. Then you look at what your zeros. Let's take a look. Relative maximum. Let's start with the first zero. Here you don't know what comes before it, so we can't really tell. Well, also it's part of the endpoint, so we're just going to keep it there. Alright, here this 0, it was decreasing, then it increased. So is that minimum or maximum? That's minimum, because it was decreasing, then it increased. This 0 here, it was increasing, then decreased, so هيدي شو maximum. Alright, وهون كمان decrease, increase, so هيدي minimum. Alright, so which one is the relative maximum? We know for sure that x equals 3 will be included. Alright, and then negative 3 and 6, how do we tell? Negative 3, again, it was high, and then since after that we started decreasing, that means in that neighborhood we are a maximum. What's the other one? 6, it was again increasing up until it reaches 6, so that should be a maximum as well. So negative 3, 6, and 3. Alright, again, when are the endpoints counted? You look at the endpoint. After it, you look from the table of variation, negative 3. After it, you started decreasing. So in that neighborhood, if you're decreasing after it, that means you were the highest point, so you're the maximum. Then you look at 6. 6, you increased till you reach 6. So that means before 6, you were lower. So that means 6 is the highest point in that neighborhood. So that's also included. So always, when you're looking at relative maximum, you always try and include, or minimum hatta, you always try and include your endpoints, and then you look at the zeros. Okay? So always the magical table of lists, the list of possible points, always the first 2 points you include are the endpoints, then you look at your zeros. Okay, this is the zero. Let's take a look. Which one is the inflection point? Okay, the inflection point will be where it changes concavity. So you have one at negative 1, at 1, over here at 4, and then that's pretty much it. So negative 1, 1, 4. Let's check that. I think the solutions are here. Part B, negative 1, 1, 4. Very easy. And then sketch the graph of h, given that h of negative 3 is this is 4. And then h of 0 is 0, and h of 5 is 3. Now, I don't know if this is going to come or not, but I'm just going to draw it for you. Okay, so let's draw this. What do they say? H of negative 3, 3, 6 is equal, all of these points are equal to 4. So let's label. This is negative 3. Alright, and then they said, they want to go to 6. I shouldn't do it like that. This is negative 3. 1, 2, 3, 4, 5, 6. This is 6. We don't come in 3. H of 0, the h of 5, they want a 5 also. Alright, let's label the points. H of negative 3, 3, and 6 are all going to be equal to 4. So 1, 2, 3, 4. So you're going to have a point here, and a point here. Then h of 0 is 0, so we're going to have a point here. Alright, I should make that point blue actually. Alright, and then h of 5 is 3. So this is 4, this is 4, this is 3. So h of 5 is 3. So we're just plotting points. We know from negative 3, we increase till we reach 0. So it kind of looks like this. Alright. No, actually other way around. It's concave, it's negative, so it has to look like this. Alright. Then from 0 to 3, we're increasing. So it looks like this. Alright. Then from 3 to 5, we're decreasing. So it kind of looks like this. Alright, and then from 5 to 6 we're just going to increase. So this is the graph. Is that correct? Yes. Alright, nice and easy, not too hard. Now be wary of the concavity. What I'm trying to say is don't just connect two lines, okay? Kind of make it curved. تمام. It's not like this. That's wrong. I don't know if you're gonna get marked down for it, but look, since you put that it's negative, that means it's gonna look like this, concave down. You get what I mean? So this is why I decreased it like this, not like this. This is a way to decrease. This is another way to decrease, from this point to this point, this point to this point. But the problem is I'm concave down, so I have to increase. I have to decrease in this method, not this method. All right. That's why I originally decreased it like this. Anyways. So this is for question 2 on, and then let's look at question 2 over here. Alright, so this is recording. This is over here. Last question. Very easy. Again, this is the graph of G prime, and they're showing us the interval from -3 to 3, and determine the values of x for which has relative minimum, find abscissas, so on and so forth. Now, the thing is, how can I say this? Yeah, we can still look at it like this. Same thing. All of this, it's best to do the table of variation. So let's do it. I'm still recording. Yes, x, f of x, f prime of x, f double prime of x. So easy, wallah. Akid now it's g, so like you can't say f, you have to say g. But please, yani, in the exam, don't put f, put g. But again, it's not a huge problem. No, actually, it is a huge problem because later on they talk about f of x. So please make sure you put g, huh? It doesn't have to be f. It can't be f in this case. When they say g, you have to put g. I'll just put it g, g, g. Alright, let's take a look. What's going on? You look at -3 to -1, it increases. So -3 to -1, we have an increase. Alright. Then from -1 to 1, it decreases. Alright. Alright, then from 1 to 3, we increase again. Cool. So what does that mean? We have a positive double prime here, negative double prime here, and a positive double prime over here. Cool. Second thing is to look at our zeros. We don't really know much about our zeros. Over here we just have, we know there's a 0 somewhere here, a 0 at 0. So let's put the 0 at 0. And a 0 over here. Again, we don't know where it is exactly, but it's somewhere there. You can't take a guess and say -2, and you can't guess and say you can say 2 because you don't know for sure. And I'm looking at the way this person solved it here. Well, they just put -2 and 2 without really saying why, but you can never know for sure. So that's why you need to check انه شو اسمه shit. Yeah, you have to check it to be exact. In the exam most probably it's gonna be -2 and 2. But you know, sometimes like if I was to correct it, I'd tell you, how. How'd you get that? Alright? You could say maybe it's symmetrical. That I guess is a valid excuse. But how do you know it's symmetrical for sure? Anyways, just if you see this in the exam, don't waste time. No, it's in the middle between these two because it's symmetrical. This one they gave it to you, it's passing through 0, so that's how you know it's symmetrical on both sides. With this one also, because this is obviously right angle. Anyways, I'm not gonna talk a lot. This is -2 and this is gonna be 2 because it's in between 3 and 1. This is in between -1 and -3, so I'm just gonna put -2 and 2. So determine the values of x for which there is a relative minimum. Always, the first two things that you include are the endpoints, right? And then you look at your zeros. Oh no, we're not done here. We're not done with the table of variation. We got our zeros, nice, but we still need to fill in the g of x part, right? So from -3 up until -2, we're under, so we're going to be decreasing. Then from -2 to 0, we're above, so we're going to increase. Then from 0 to 2, we're going to be below, so we're going to decrease. And then from 2 to 3, we're going to increase. Alright, so we did that. So now, like I told you, minimum, first thing you state is always your endpoints, Then you list your zeros. Which zeros here could be a minimum? Could it be this one? We're decreasing, then we start increasing. Obviously, that's a minimum, because minimum means decrease, increase. over here this is a maximum. Why? Because it increased then decreased. Over here again this is another minimum because decrease increase. So it could be at -2 and at 2. These are for sure confirmed. Let's check -3. You look at -3. After -3, what happens? F of x begins after -3, what happens to g of x? It decreases. So you go -3, what happens? It decreases. So isn't it high? So if it's high, then what does that mean? It's a maximum. It's actually not a minimum, it's a maximum. Let's check 3. 3, you increase to reach 3. So if 3 is, you reach it after increasing, could that be a minimum? No, it means it's a maximum. So these are your only two relative minimums. Then part B, find the abscissas of the point of inflections. Point of inflection, again, you just look at where it changes sign. So we're going to put -1 and at here at 1. Nice. Alright, express g double prime as a piecewise function. Now, basically, this is a straight line. When you have a straight line and you derive it, this is g prime. They want g double prime. When you derive g prime, you get g double prime, right? And isn't g prime a straight line? What happens when you derive a straight line like 2x? Wouldn't you get 2? You get a constant. Alright? So over here, this straight line, if you derive it, you're gonna get a straight line. The idea is, what is the number you're gonna get? Okay? So let's take a look. You need to express this as a straight line. It's so easy, just find the slope. Okay? The answer you get will always just be the slope of this line. What's the slope? y2 minus y1 over over x2 minus x1. And you're gonna get, that's 2 over 2, which is 1. So the slope of this line is 1. So that means g double prime here is gonna be 1. How about here? Same thing, the slope will be -1 when you do it. I'm not gonna calculate, you can calculate y2 minus y1 over x2 minus x1. Then over here, the slope will also be 1. So that means g prime prime is equal to 1 for what? X in between -3 and -1, right? And it's g prime prime is equal to -1 for x in between 1 and -1, and it's equal 1 again for x between 3 and 1. How would you write this as a piecewise? This isn't your answer. Alright, how would you write this as a piecewise? You write it like this: g double prime is equal to, and you open like some fancy bracket, okay, 1, -1, 1 for x in between. Now I need to make sure and confirm. أكيد is in between -1 and -3. This is true. Then here it's for x in between -1 and 1, and then here it's for x in between 3 and 1. So what do I need to check is greater than or equal, less than or equal. When do you put it? So let me check. So I'm looking at the solution, and I think these are correct. Actually they put it less than -1 directly. If we're looking at an interval defined, they're saying that it's defined on -3, 3. So I don't think you can say that it's less than -1. So that's I think that's wrong from the solution side. Then I looked at the bounds, whether you can include -1, and I'm thinking, no, you're not allowed to include it at any. So you keep it strictly less than, strictly in between. Why? Because, by the way, the derivative doesn't exist at these points because these are corner points. Okay, so you can't include them. Type, so you keep it like this. This is g prime prime of x again. Okay, and if you think it should be x greater than 1 or x less than -1, I think you're wrong. If you have a valid explanation, please put it in the comments, but I don't think it's correct because they said that the function g is defined on the interval this. So if it's defined on this interval, then on the other intervals, such as less than -1, it will not be defined fully, and therefore you cannot have a second derivative. So I don't know, but this is the answer I would write in my exam. If you want to copy it, feel free to copy it. Part D, find f prime of x and f double prime in terms of g prime, sine x and cos x. It's so easy. Okay, basically they told us this. Where is it? Somewhere. Where did they say it? Hold up, let me find. Yeah, here. They said it here. basically f of x is equal to g of sine x. How do we find f prime of x? Basically we gotta derive both sides. So it's gonna be derive g of sine x, it's gonna be g prime of sine x times the derivative of what's inside, which is cos x. So that's the first one. First mark here. Then second derivative, you gotta derive this again, but now you gotta do product rule. Alright? So what do we use for product rule? U is g prime sine x, v is cos x. So u prime is gonna be g double prime sine x times again the derivative of what's inside, which is cos x. Then v prime will be negative sine x. So use the product rule, u prime v plus v prime u. So it's gonna be g double prime sine x cos x cos x. So you could just put cosine squared x because it's u prime v, yeah? Plus v prime u, so negative sine x g prime sine x. This has to be under the bracket, huh? This is your answer. Alright, so find f prime of x and find f double prime. We got it. Then they said show that f has an extreme point at abscissa x equals 0 and state whether this is a maximum or minimum turning point. Alright, show that f has an extreme point. If we want to show f has an extreme point, yani what do we do? F prime of x is equal to 0. Didn't we just find what f prime of x is equal to? Yes. So that means we're going to say g of sine x cos x is equal to 0. Sorry, Hona, I meant to say g prime, huh? G prime of sine x cos x. No, this is the derivative. G prime of sine x cos x equal to 0. They're saying, no, show that there is an extreme point at abscissa x equals 0. That means when you substitute 0, our f prime of x should be equal to 0. So let's substitute 0. So g prime of sine 0 cos 0 is equal to 0. What's sine 0? 0. So that means we're saying g prime of 0 times cosine 0 is equal to 0. Cosine 0 is 1. I'm just going to remove that. So g prime of 0 equals 0. How do we check this? Go up to our graph, because this graph is the graph of g prime. Check 0. How much is it? It's 0, because the point is 0, 0, right? So g prime of 0 will get me 0. So that means 0 equals 0, and you say true, there exists an extreme point. Now, how do we check whether this point is a maximum or minimum? All you have to do is check how much is g prime before, how much is g prime. Sorry, all we have to do now is check how much f prime of x is before 0, and check how much it is after 0. So let's choose a point. I guess we can choose 1. So let's check f prime of 1. What's f prime of 1 going to be equal to? G prime of sine 1 times cosine of 1. Anyways, so you just do this on the calculator. Cosine 1 is going to be like approximately 0.5. Sine 1 is going to be like approximately 0.8. So that means g prime of 0.8 times 0.5. What's g prime of 0.8? Again, go to the graph. Around 0.8 is over here. What's going to get you a negative answer. So you say is negative. Type. Now we don't care about the number, huh? We just want to see if it's negative or positive. So let's check f prime of negative 1. It's going to be g prime sine of negative 1 cosine negative 1. Cosine negative 1 is 0.5, around 0.5. Sine negative 1 is negative 0.8. So you check what's g prime of negative 0.8, which is over here. So it's positive. Alright, so over here we're gonna have a positive answer times 0.5, which is what? A positive answer. Alright, how did I get negative here? Because like I told you, g prime of 0.8, go to the graph, it's negative. So it's a negative number times a positive number, which is negative. So before 0, it's negative. After 0, it's positive. That means it was decreasing, then increasing. So what's that? It's a minimum. Alright, so that's it. Thank you guys so much for watching, and good luck in your exam. See you.